Okay, let's start. So, my name is Fyodor. I'm from Nizhny Novgorod, Russia. I work for a company called Mira. And the slide says that I'm Android solution architect. And that can be confusing for some of you because I don't write applications for Android, actually. I work on a layer below. I work on the operation system itself. So, if you are application developer, and you've heard about Project Treble, I hope some of you did, you may think that this talk will not necessarily be useful for you, more of an entertainment, because, well, you application developers, you don't care what happens in the system, right? There's the API, and what happens below, nobody knows. Well, I'll try to persuade you that there is actually some value in what I'm saying for you. In fact, that it's actually quite useful for you because I try to think about Google's strategy, what they want to do with Android, and you kind of dependent on their decisions. So this might be useful. So let's see if you will be interested. How it's all started. Our company worked with Android devices for some time, and about 4 or 5 years ago we became partners with one SoC vendor, so silicon chips vendor. So they didn't know anything about Android. And we actually knew something, so we started to help them by building Android specifically for their SoC and customizing it for final device manufacturers. And we started way ago with KitKat and gradually upgraded to newer versions, one after another, and that was most of our occupation actually, and that was until we hit Oreo. And this guy was different. And the reason it was different because it was difficult. We spent 3 times more effort to upgrade to Android Oreo as opposed to how we upgraded to previous versions. And that was because of Treble. Project Treble turned out to be difficult to upgrade to. So today I'm going to talk about what is Project Treble, if you've never heard about this or heard a little but don't really know, why Google did it, why they needed it, what are components of Treble, are there any problems with it, and maybe something about Android 9. With regards to Treble, if there is anything new there about Treble. So this is the idea for today's talk. So if you start Googling Android Treble, and I had to do some research for this talk, believe it or not. So I went to read a bunch of interviews from guys from Google, because I don't work for Google. We're not even partners with Google, so I have no idea what actually happens there. But I could read what's available on the internet, and this research, you have a bunch of interviews about Project Treble from Google, and if you read them, the overall tone is like proud, celebratory. There are 3 quotes here from guys from Google, senior guys, and it all boils down to the same thing, that Project Treble was amazing. It was huge. They re-architectured the whole system. The whole team of 300 engineers worked on this for a year, and they did it, so good job, right? If you start thinking about it, you say, wait, 300 engineers for a year working on re-architecture. Just imagine that you come to your managers and you say, hey, we need to re-architecture our product. It will take 300 man-years. Please approve it. what do you expect would happen? But they managed to persuade their managers to do it. So they managed to justify this effort. And that's not us, it's Google engineers, right, in California. God knows how much these guys get a month or a year. So this is quite an effort. Even Google probably thought a few times before paying for it. But that's why it's interesting to me. First question, why do you spend this effort? And if you see what's officially Google talks about Project Treble, hear this. It's re-architecture of Android that happened in Android 8 to make upgrades to new versions of Android easier and cheaper for device vendors, right? Well, you application developers, I assume most of you Android application developers, and you know why it's important to upgrade to newer versions of Android. Because fragmentation, because we have older versions. But how Treble was supposed to help? Well, there's only this picture, right? And it doesn't tell a lot. There is some vendor, there is framework, they kind of mixed. Now you have original vendor implementation still work with new framework, but what's framework and how it's different from vendor implementation, what is this? To understand this picture, you need to understand this one. This is the architecture of Android operation system, how Google writes it. So you've probably seen this picture from Google. And by the way, in my presentation, you'll find a lot of pictures from Google with my scribbles on top of it. Like this one, application, that's from me. The rest is from Google. So this on the top, there where I put application, that's where you live. Like tip of the iceberg. So you guys up there. And below there is a like hell, like with many, many layers of hell. The deeper you go, the worse it gets, right? Well, on top you have applications and they rely on framework, on API, right? But API itself is implemented by something called system services. And that's actually the majority of operating system Android. System services, bunch of subsystems for Bluetooth, for audio, and for all the rest. But the actual works happen on the lowest level in Linux kernel. So that's why some people say that Android is actually Linux, just with something on top. Of course, this something on top is like 10 times as big as the Linux kernel, but, well, yeah, it's something on top. But an important part for us lies in between Linux kernel and system services. That's HALs, hardware abstraction layer. So this is like a layer of libraries which connects different drivers implemented by different chip vendors, different manufacturers, and they basically implement like API, which Google specified for system services to work on top of. And here I put a separation between stuff that Google does and stuff that chip vendor do. You see, there is a certain separation. Google does the framework. They developed originally all these multiple services. But the drivers, the kernel, and the HALs, they come from the vendor of the chip, vendor of the hardware. And then they all modified by actual device manufacturer. But this separation is important because stuff on top is dependent on stuff on the bottom. And because of this dependency, when you upgrade, it has to happen in steps, like this. You see, when Google released new Android version, it only works on Pixel, and it doesn't work on any other device, because only for Pixel you have HALs, you have kernel, which is compatible with this new framework. And before chip vendor, silicon manufacturer, releases version of the HALs and the drivers which is compatible with the framework, device vendor couldn't do anything. Who's SoC vendor? Who's a silicon vendor? It's like Qualcomm. And device manufacturer is Samsung. So when you ask Samsung, why didn't you upgrade to a new version of Android? The usual answer is, we're still waiting on Qualcomm. That's why they're waiting. Basically, they say, until Qualcomm does their job and gives us a version of Android which works on their chip, we can do nothing. We cannot test anything, so we wait. So there are like several parties involved. At the end, there is a carrier, so that's like AT&T or Megaphone in Russia, so mobile operators. They also can customize the device if they sell them, but this is relatively minor. So two major players, a chip vendor and device maker. Okay? And since all these parties need to do something, they have process, they have testing, and it all happens in steps, you have like 6 to 12 months of upgrade time. Okay? And by the way, if somebody decides not to upgrade at all, you don't get an update on your device. That's usually the story. And as a result, the picture that you all know as developers, right? Fragmentation of the Android ecosystem between different Android versions. This is the last statistics that Google published on Play Store. It was at the end of October. And can you find a Pi version of Android in this chart? No, you can't. It's less than 0.1%. On the other hand, you have like 3 in 10 people running Jelly Bean. So statistic means that probably one of you here has Jelly Bean in their pocket. He can be sitting next to you. Beware. Compared with iOS, they released a new version of iOS in September. In less than a month, in October, they had more than 50% conversion to the latest version of iOS. And for Google, the only competitor is Apple. So that's, I mean, about this, you care as mobile developers, users care, but Google cares the most because they lose money over this. So, why it took so much time? I kind of told you about this already, but let's reiterate. And interesting part, that Google already had the solution way back from the day one. I mean, on the application level, on the API that you all work with, you kind of have this wonderful thing called backward compatibility, right? When Google released a new version of Android, your application do not stop to work for some reason, right? That's because all the API still works. But guess what? Where I have the red line here? No backward compatibility. Each new version of Android meant new API works, old API doesn't. And as a result, you have all this wonderful mixture between upper layer and lower layer interdependency, all messy, upgrade takes a lot of time. And that's kind of a definition of technical debt to me. I mean, they had it from day one, and that's kind of an architectural error. It's not about that somebody did some bug, it's just like in the architecture, there was a flow. And this flow, that's ruins the whole thing, and not ruins it, but I mean, makes upgrades difficult, and that's bad. So now you understand why Google wanted to do it and what they tried to fix. Let's move to more technical part of the presentation, what they actually did. And they did a lot. There was like a million lines of code. This is their estimate on the change. 1 million. Well, 300 engineers in a year kind of makes sense. But I'm not going to talk about all of this. First, because I don't have time. Second, because stuff that is not in bold is kind of irrelevant. You can understand the Treble without it, and it's a bit boring, so I don't care. The most important part is HALs. I already mentioned this, hardware abstraction layer, but this is at the center of the Treble. They needed to have this API versioned, and they solved this in steps. There were like 4 steps to this. Let's go through all of them. First step is how it was before, how legacy implementation. Before Treble, HAL was essentially just a C library. And the interface, API for this library, was defined by Google as just a bunch of C headers in a specific folder. So you get new version of Android, you get new headers, old headers don't work. And manufacturers, they could modify these headers. They could add their own APIs, they can change it. So basically, oh, you have new versions of Android. Google changed APIs, headers that you changed previously, so now you need to implement something that wasn't there before, and now you need to merge it with your implementation. So that's what SoC vendors did mostly. So the problem was that they didn't have versions. All the APIs stopped to work. So that's the first thing they did. They said, let's add versions. But they didn't want to add versions as like more C headers. No. They said, we'll make something easier, right? We will invent our own language. So they did. They invented a language and called it HAL, HAL Interface Definition Language, which is kind of like ADL that most of you probably familiar with, but even if you're not familiar with ADL, I'm not going to show HAL on the screen anyway, so who cares? And most of the people who write in HAL actually work for Google, so again, only they care about this. The good thing about HAL, well, it has versions. It kind of, when you write an interface in HAL, you can convert it to either C header files as before, or you can convert it to Java, which was like a secondary nice addition. First you have versions, but now you also can write HALs in Java. But that was, so problem solved, right? You now have versions there, like in a nice format, new language, and Google implemented the connection to legacy implementation, so it's all fine. Well, no, this is just step one. This is called pass-through HALs because HAL is still a library. A library which is linked into the system service, which still means that you need to recompile and relink everything when you build a new version. So they say, no, we want to have all the HALs as a separate services. We don't want to have them as a libraries. That's called binderizing them from binder. Again, you're probably familiar with binder because that's IPC in Android, like a driver to connect services. And the only true way to connect to a HAL right now is through binder. Google created these services for all the HALs. They basically created the wrappers, they created the separate services, they created the HAL interfaces, and they made framework work with different versions of API. Basically, it means that if Google develops a new version of HAL interface, old version of HAL interface still works, but some of the functionality that they've added in new version doesn't work in framework. So basically, framework was complicated, Then they needed to create new services, and there is about 60 different HALs. So 60 different components to the system, and they needed to change all of them on all the levels. And that is what probably took all these 300 man years. Not all of them, but quite a lot. Majority of the effort was here, I guess. So, Google did most of the work, by the way. You see this red legacy HAL vendor implementation square? It means that if you do everything correctly, you can put your previous implementation of the HAL in this place, in the right place, and it will work, in theory. In practice, for us, it was kind of pain, but in theory, it should be nice. But Google didn't stop here. They said, okay, we have created these wrappers for you, services, but guys, now you have idle, now you can write your HALs as a separate services in either C++ or Java. So actually, you can throw out everything we did and implement your own version of the HAL. Do you know how many we implemented ourselves? 0, yeah, correct. That's because Google already did most of the work for us. So we can say, why would we do that? Why would we spend all the effort if they already did it before? This would not be true for all of the people. I mean, for guys like Yandex who released their phone recently, they probably did something because they were new, they didn't have legacy. Then maybe guys like Samsung or Qualcomm who like to customize Android, they kind of famous for it, for customization of Android. They probably like the opportunity, they will use it, but smaller guys like us, well, we didn't bother, and not a lot of people will, in my opinion. It will be kind of difficult to see, but that's my personal opinion. So HALs, okay, you know, versions, how do you check them? And when do you check them? Well, kind of the obvious answer during the upgrade. So when you upgrade, you get OTA package to your device, there's a new framework, and your phone needs to decide if he wants to live with this new framework, and framework needs to decide if he wants to live on this phone. If all the HALs, all the hardware is actually compatible with the framework. To decide this, Google introduced something called vendor interface object. This is basically this red line I drew on the slides previously. Vendor interface object is kind of two manifests and two matrices. By the way, manifest, this device manifest, has nothing to do with the manifest you know. Google just is not very inventive about the name, or they like the word manifest. So there's this third thing called manifest in Android, and it's completely different from the other two. So yeah, new thing called manifest. In manifest, you have the information about what you have on the device. HAL versions, SLinux policies, version of the kernel, version of the libraries, this stuff. And then frameworks checks if it's compatible with this version of the HAL. Like, if there is at least one HAL which is required for framework, and there is not such a version of this HAL on the device, upgrade will fail. The opposite is also true. Device checks that if there is a new HAL comes in OTA upgrade, device check if it's compatible with this new version of the HAL. So actually they kind of check each other, and one of the interesting things about this is that in theory device manufacturer can use it to prevent upgrades to newer versions of Android. I mean, they can just write device compatibility metrics in the way which will prevent the upgrade to newer versions of Android, newer versions of framework. That's kind of opposite of what Google wanted in the first place, but they had to give this opportunity, and we'll see if any of the device vendors actually use it. I think Google will kill them if they do, but who knows? Maybe, yeah, Chinese, I think Google would like to kill a lot of Chinese vendors already, but this is not all. So during the upgrade, you get this new package, but before Treble, it was difficult to put it on the flash. That's because on the flash, everything was residing, most of the system was residing in /system partition. And that meant that HALs, stuff that vendors wrote, and the framework, stuff that Google wrote, was all in the same partition mixed. Google said, we want to separate it, so now they created this mandatory /vendor partition. /vendor was advised to have previously, but it wasn't mandatory. Now it means that all the HALs, everything that SOC vendors, chip vendors do needs to be in this partition or in some other ones, but vendor is the most important because HALs go there. And that created a bunch of problems on its own, because if you didn't have vendor partition, you kind of screwed, because now you have all the devices in the field with your users, and you need to repartition the flash on these devices, and this can easily break the device. So it's like your phone becomes a brick after the upgrade if you, for example, lose power during the upgrade. So a lot of people decided that they're not going to do the upgrade to Android 8 for their existing devices. They just say that, okay, we create new devices with Treble support, but we do not create, we do not update our existing devices. For us, for example, we had vendor partition, but it was 256 megabytes only, because we only stored some logs there. So now we need to squeeze all our HALs in this vendor partition. This is kind of fun. We did. Now we just hope that we don't have to put anything else there. But they had to do it, so I think they decided to bite the bullet. And the last thing I want to talk about is a vendor test suite. That's how they checked that device vendors actually followed all these new wonderful guidelines. So if you know how Google certifies the devices of different vendors, it's with this thing called GTS, Google Test Suite, which is basically CTS plus VTS. Well, the GTS is kind of small thing over there, but overall it's called GTS. And CTS was about 200,000 unit tests. So you basically need to pass a lot of unit tests to certify your device. And you usually do, because without it you are not allowed to install Play Store on your device. And now you have another bunch of unit tests called Vendor Test Suite, VTS, and it checks the same thing, but on the level below it checks that the HALs work as defined in API, that kernel version is correct, that libraries are correct. And all this, the previous one and this one, leads to the creation of a thing called general system image, or golden image. That is basically a version of Android which runs on Pixel. And the reason it's called golden image is because it's supposed to work on all the devices which support Treble after you compile it for the required architecture. So when you pass the tests, you pass it not on your version of framework, not on your version of Android, but on Google version of Android now. And this means that golden image always works on all the devices, right? This is like a dream for all custom loads creators, because they previously had to look for all the interfaces that vendors changed. Now you have like fixed interface, so this is much better for them. But for some reason we didn't see a lot of Android Pie custom ROMs yet. Sorry?
They are faking Treble right now.
They are faking Treble? Okay. You'll need to explain me how they do it. But I can guess that you say that maybe they do special code to pass the unit tests, like vendors, without actually implementing the required functionality, which I know nothing about. Please don't ask me. So to sum up, what we had before Treble, HALs were just libraries, and interface for them was just a bunch of headers. Now they are separate services. The interface for them is defined in a special language, and they have versions. That's the biggest part. Second, HALs were kind of included in OTA package during upgrade. Now HALs can be, basically you don't have to do it. HALs can be the same as were on the device, and it will be checked during OTA upgrade. Next, HALs were mixed with framework in /system partition. Now they have their own /vendor partition. And the last one is the certification. Before, they only cared about the very top level, about the application API that all you familiar with. That's what the certification cared about. Now they added a bunch of checks on 2 layers below on the platform level, and that kind of means they now have a more strict architecture and more strict process. Before it was like a nightmare to certify the device. Now it's just worse. We didn't believe that it would be possible actually, but now it is. Okay. Nice transition to this slide. Are there any problems with Treble? Well, first problem, I already talked about this for several times. It was difficult for us to upgrade to a new version of Android because you have the re-architecture, and if you have legacy code which didn't conform to this architecture, if you didn't know what Google going to do, then you have problem. Because you need to spend a lot of effort. For us, it was like usually we could bring up Android in 2 months time, new version. Now it was like 6. So a lot of effort for all the device vendor, I guess. Next, you remember there were like pass-through HALs, which are just libraries with HAL interface, and binderized HALs, which were separate services. Well, the idea was that all the HALs will be binderized. It's like separation, beautiful architecture, all this stuff. Well, you still need pass-through HALs. You see, when you do all your HALs as separate services, you get the problem. And the problem is that it's slower. Binder kind of takes time, IPC, all the calls. And with some things like graphics, you ran into performance hit, which can be seen by user on all the devices. So they said, okay, here's the beautiful architecture, separation, separate sources, all this stuff. But if you work on graphics, forget about it. Don't use it. Let's leave it as it was, right? So that's kind of, if you need to make an exception to your architecture from day one, maybe there is something wrong about your architecture. You need to look into this. Next, like I said, there was about 1 million lines of code changed, according to Google. And that usually means bugs. I mean, if you change something, you break something. Well, they probably did, but to give them credit, I haven't heard about many new vulnerabilities in Android 9, so maybe we just haven't found them yet. But I expect we will. I mean, there's like universal law. If you write new code or you change something, you break something. The last point is kind of philosophical. There is always a balance between beautiful architecture and strict enforcement of the rules and customization. So now they kind of moved to strict enforcement of the rules, they tighten the screws, they have all this new VTS tests and all this stuff. That makes customization and creation of the new stuff, of the stuff that is not intended by Google originally, kind of difficult. That can even come to a point where phones will be more and more the same. Google states that they want to walk this thin line between good architecture and certification and between the ability of device vendors to customize, but it will be difficult even for them, and we'll have to wait and see if they succeed. And the last one, well, upgrades kind of still difficult. Only recently device vendors started to release Android Pie devices, upgrade their devices to Android Pie. Samsung didn't do it yet. Officially, they only plan to do it in the beginning of next year. And why is that? Well, you see, they kind of made the right thing. They separated SoC vendor stuff, right? So SoC vendor, basically, Samsung doesn't have to wait for Qualcomm now. They can say, move forward without waiting for them. But they still need to do all the stuff they did previously, because hardware manufacturer actually modified everything. They modified HALs, they modified services, they did all this, all their custom features, and they still need to propagate it. So basically, it's not like they moved from step 1 to step 5. You remember this picture, right? It's like they just made steps 2 and 3 parallel. So it's not like, yeah, it's faster. I mean, previously you had much slower upgrades than now, but it's still not one day, not even 1 month. It's still a lot of work for hardware vendors, and I don't know what Google can do about it, actually. Maybe they're thinking about it, but I don't have to do it for them. So, in August, we had Android Pie release, and it was very interesting for me to look how Treble did. Not to see what they changed in Treble. There were some changes in Android 9 about Treble, but it was minor stuff, relatively minor stuff. They had to, I think, compensate, catch up. I mean, for a year, they didn't invent any new features practically. They only worked on Treble, so that they needed to introduce new features. But so in Android 9, there was not a bunch of stuff about Treble, but Android 9 was first released after Treble, right? So upgrade would become easier if you already support Treble. And that means that Pi is like the first canary for us. We can see if the idea works. So right now I checked on the internet, maybe I didn't find anything, but basically there are now 18 devices supporting Android Pie, having officially upgrading to Android Pie. 3 of them are pixels, so they don't count. 4 of them Android One. Android One is a program where Google does the Android for different manufacturers. So it also kind of doesn't count because it's still Google doing all the work. But there are 11 phones from other 5 vendors who actually managed to upgrade to Android Pie, which is impressive if you compare it with the previous experience of upgrades when some vendors upgraded like in a year or never. So now it looks like that most of the vendors will try to play with Treble at least, see if it's actually worth their while. They'll try to do the upgrades, but on the forums, if you read them, there are on Reddit, there's like I've seen a post titled "Was Project Treble a failure?" based on this. So basically, for now, we kind of in between. I mean, as a community, if it worked or not. The last point here is more interesting to you. You know about this. I assume that now you need to target API level 26 at least in your applications if you want to put them on Play Store. And basically in a year it will be API level 28, I guess. So Google enforces the new versions of API for application developers, and the reason I bring it here is not because it's somehow related to Treble on a technical level. It's not. But on a business level, it makes great sense because it shows you overall strategy of the Google to push for new releases. I mean, with phones, they had Treble, and now they're going to push all the device vendors to upgrade, saying that they cannot any longer blame silicon vendors for the delay because of Treble. And with applications, they're going to push you to upgrade. So they want to be like Apple. They want to upgrade faster, and they want all the developers to develop using latest API and all the new features they develop. And they want you to use it now and not in 2 years when some of the Pi devices will be with your users. So to summarize, what was Treble? Treble was a fix for architectural mistake that was there in Android from day one. It was there for a long time, and Google has to pay for this mistake a lot, but that's Google, which means they don't like to pay alone. So we also paid for this mistake, and all the device vendors did, but what are you gonna do? Still, despite all of this, the question remains whether they succeeded or not. And if you look just at the technical perspective, I would say their claims are justified. All these guys who say that they've done it, engineers, they really did. I mean, Android 8, Android 9, they work. Not a lot of people notice Treble. I mean, they changed everything down below, everything, and it doesn't crash. It's not that slower. So they set technical targets for themselves, and they achieved what they wanted to achieve. But for the business perspective, you need to understand that their goal was to have devices upgradable to the latest version of Android for 4 years. That's the target they set to themselves. And it's only been a year, a little more than a year, but still not enough time to say if they succeeded or not. Even the results we have right now with Android Pie, they're kind of mixed. I mean, there are still like these long threads on Reddit and everywhere saying they succeeded, they failed. The answer we'll get like in a couple of years, so ask me then. And that will be the conclusion of my talk. I'll take your questions now. Thank you. In English, in Russian.
Я вижу, вы разбираетесь в топике. Я читал такие интересные мнения о теории заговора в Гугле, что если Oracle и Google все-таки не договорятся и в конце концов выяснится, что очень много надо будет отчислять Oracle за каждое устройство, да, им легче будет вообще отказаться от Android, поставить что-то на его место и сделать эти API. Правда ли это? И что вот этот hardware abstraction level и то, что они сделали с Treble, да, поможет это, например, быстренько заменить на какую-нибудь функцию или что-то подобное, чтобы мир изменился и не платить. Вот.
Ну, любое разделение архитектуры, то есть большая модульность, она позволяет, она способствует, скажем так, миграции в любом случае. Но сказать, что это прям вот так вот, что это легко будет, ну, не, это задача на там Treble семечками покажется, мне кажется, если так это сравнивать. Но теорию заговора я тоже люблю. Проблема в том, что у меня нет инсайдерской информации, я ориентируюсь только на открытые источники. Поэтому, если вот мне там какой-нибудь Сережа Брин будет в ухо шептать, то я бы сказал, а так, извините.
Спасибо большое за доклад. Такой вопрос. С приходом Project Treble будет ли проще энтузиастам делать кастомные имиджи, портировать там новые версии Android и так далее?
Формально должно быть да. Но тут вот как раз был разговор о том, что, возможно, какие-то производители устройств не совсем, скажем так, следуют, не совсем попадают, так скажем, в лоно Святой Матери Церкви и следуют всем наставлениям Гугла, всем там формально, если, давайте так скажем, если вот, допустим, Samsung выпустит девайс, который Treble compatible, то они должны следовать формально тому API, который установил Google. Соответственно, если раньше они могли просто не пошарить с людьми вот эти хедеры, и люди не знали, с чем им линковаться, то теперь как бы люди могут сами взять, сгенерить хедеры из хайдловских интерфейсов, которые открыты, и вроде как оно заработает. Но по факту, вот, во-первых, все как бы звери равны, а некоторые немножко равнее. То есть Google с разными вендорами по-разному себя ведет. Во-вторых, как тут уже сказал, и вендоры имеют некоторое пространство для маневра. В общем, на данный момент как раз вот статья в Reddit, которую я упоминал, там, по-моему, в комментах один из серьезных аргументов в то, что Treble зафейлился, это то, что кастомных ромов на девятке до сих пор нет.